All right, let's take a look at your Unit 3 exam. 3 unit exams down, 4 to go, and a comprehensive final. So there were 3 sections. There were 32 multiple choice questions, each worth 1 point apiece. There were 12 vocab sections, each worth 2 points apiece. And then there were 6 short answer, each worth 3 points apiece. So for a total of 74 points. And I went ahead and spotted everybody 5 points. So instead of taking it out of 74, I took it out of 69. So the first question was about the sun. It says, what is meant by the solar limb? And the best answer there is B. It's the visible edge of the disk of the sun. Question 2 was about the size that a star can be, the masses. And the best answer there is D, 0.08 solar masses to 100 solar masses. Question 3 says, what feature associated with the Earth actually helps protect us from charged particles associated with the sun? And the best answer there is A, Earth's magnetic field. Question 4, what is the value of the Chandrasekhar limit? That's 1.4 solar masses, so B is the best answer for 4. X-ray burst, now this was probably, we talked about a lot of different energetic events, and one event is where you have a neutron star that it has a swollen companion and the neutron star gets dumped on, and the accretion disk forms these what we call X-ray bursts. So actually A is the best answer there. Question 6, how does the mass of a main sequence star affect how long it will be in that stage? Well, the more massive it is, the more quickly it ages, and so B is the best answer there. The more massive the star is, the shorter time it will be on the main sequence. Question 7, those ripples created in the fabric of space and time are called, the best answer there is gravitational waves. They can be used to detect interactions of dense objects such as white dwarfs, neutron stars, and black holes. Question 8, which of the following statements about our sun, that's supposed to be a little heart there, which of the following statements about our sun are false? So A, is this false? No, A is true. Hydrogen is being converted to helium. B, is it false? No, it's true. The sun is creating energy according to E is equal to mc squared. C there. Is it true that the outer layer of the sun's atmosphere, the corona, is so hot that nuclear fusion occurs there occasionally? No, that is incorrect. And D is correct about the sun. The sun is losing mass at a steady rate. So, question 9. Which of the following can be said about how long it takes for a protostar to arrive at the main sequence? And again, the more massive the star is, the more quickly it moves from protostar to main sequence. So D is the best answer there. Question 10, how would you generally describe luminosity and temperature of white dwarfs? Remember, on an HR diagram, they are kind of the lower left. So actually that means since they're lower, their apparent brightness Since they're lower, their apparent brightness is low. Their luminosity is low. So that's A, and since they're to the left, that means their temperatures are high. So A is the best answer for 10. Question 11, which of the following correctly describe that other brightness scale we call the absolute magnitude, capital M? And the best answer there is B, it's the apparent brightness as an object would appear as if it were placed 10 parsecs away. Question 12, which of the following terms or phrases most closely associated with space weather? So actually of them, B, solar activity is most closely associated with space weather. 13, how do we detect the motion of stars moving either directly toward or away from us? We use the Doppler effect or Doppler shift in the spectral line. So B is the best answer for 13. Question 14, which of these is an incorrect statement about the phenomenon we call the pulsar? So I'll go right to the incorrect one. It's incorrect to say that D, pulsars are a signature from a nova event. It is true to say that A, pulsars can be oftentimes found amidst a supernova remnant because a neutron star is creating the pulsar, and neutron star is one of the 2 options after a massive star blows up, creating a supernova. It'll either be left with a neutron star or a stellar black hole. B, it's also true to say that with regard to pulsars, we can use the lighthouse model. And it's also true to say, C, that pulsars are created from spinning neutron stars. Question 15, how does apparent brightness vary with distance? And the best answer there is B, that apparent brightness will decrease with increasing distance. So things become dimmer as they are farther away. Question 16, according to Einstein, a light radiating yellow in the vicinity of a neutron star, due to the strong gravity of the neutron star, will be redshifted or shifted to the red part. So C is the best answer there. Question 17, what is the minimum mass a star must be as its main sequence to ultimately form a stellar black hole? And we talked about that being 25 solar masses or greater as it's a main sequence star. Question 18, I wanted you to list those 7 stellar spectral types in order of the coolest to the hottest. So it's O, be a fine guy, kiss me backwards. So A is the best answer there. Question 19, which of these actually list the least complicated to the most complicated types of fusion that can happen inside the cores of stars? So here we have hydrogen forming helium, helium forming carbon, carbon forming neon, neon forming oxygen, oxygen forming silicon, and silicon is fusion, is forming iron. So B is the best answer there. Question 20, as a star in its main sequence stage, how are mass and luminosity related? So D, there is the more massive the star, the more luminous it is. That's the best answer for 20. Question 21. Photons of light shining from within the vent horizon of a black hole. The best answer there is C, will not escape the gravity of the black hole. Question 22. In astronomy, to what are we referring when we talk about the random walk? And the best answer there is A. And so if you use this in your description of the interior of the sun for the last page, the random walk refers to A, that very long path that energy takes from the sun's core to the surface of the sun through the radiative zone. Question 23, of these HR diagrams with these clusters of stars, which clusters of stars is the oldest? And so I was actually after the one with the lowest turnoff point. And so if you look, B actually has the lowest turnoff point. C is close, but B is a little bit lower. So D is the best answer there. 24, in this figure, which stars are the youngest? And so actually, if you group A, B, C, or D, and it's these guys are the youngest. These are the baby ones. So the best answer there is A, group D. Question 25, which of the fine layers of the sun is the hottest? And these are all kind of layers of the sun's atmosphere. So as it turns out, B, it's the corona, the outermost layer of the sun's atmosphere is the hottest. Question 26, which of the following is not specifically associated with an active sun? And D, solar wind is an ongoing thing, not associated with the sun is both active and passive. We're going to have solar wind, but the coronal holes, solar flares, sunspots are also all associated with an active sun. Question 27, which of the following do all stars in the main sequence stage have in common? And the only answer that's true about main sequence stars that they have in common is A, that they are fusing hydrogen to form helium. Question 28, which of the following is not a feature of the sun that is always present? And solar wind is always present, granules are always present, the corona is always present. Those prominence will come and go with the activity of the sun. Question 29, the method by which black holes can slowly evaporate is known as the Hawking process. Well, actually, that process speeds up as the black hole becomes smaller and smaller. So, question 30, how many years in general are there in a single solar cycle? That would be 11 years, so A is the best answer. Question 31, how can the mass of a star be determined? Best answer there is B, by observing its motion in a binary star system. Question 32, what two conditions are required in the core of the sun so that nuclear fusion can occur? The best answer there is C, high pressure and high temperature. Then we go into the vocab questions, and it is possible to get, in fact, this first question is an example of it. It's possible to get 1 out of the 2 points here. Question 33 says, as a low-mass star leaves its red giant stage, it gives off its outer material to form these beautiful objects. And if you put nebula, I gave you 1 of 2 points. But more specifically, it's what we call a planetary nebula. Question 34, the outer material of a massive star that's spread should be spread instead of spready. Spread in all directions during a supernova explosion is called a supernova remnant. So what is after 34? Question 35, this is the region associated where a black hole beyond which nothing, not even light, can go fast enough to escape. That would be the event horizon. Question 36. If a protostar's mass is less than 0.08 solar masses, then that object will ultimately become or is a brown dwarf. Question 37. The fact that our sun balances the inward force of gravity with the outward force of energy that it's creating in its core is called hydrostatic equilibrium. Again, 37 was another example where it's possible that if you just put equilibrium, I gave you 1 of 2 points. Question 38, I was after molecular cloud is a region of space where bunches of stars can be born at the same time. Question 39, the amount of energy being emitted by a star per second is called its luminosity. Question 40, very low mass stars whose mass is between 0.08 and 0.4 solar masses ultimately, what we say, convect their spent hydrogen, they convect the helium upward so that they just kind of end their lives as a red dwarf. 41, I was after spaghettification. I never know how to spell it, but spaghettification is that if you were to fall towards a black hole, the process by which you would ultimately die. Question 42, this was a hard one for a lot of you, but I was after the term space-time as kind of that fabric that can that objects can create dents in. So, question 43, the type of binary star that's detected by watching the light from the pair of stars dip down as one star passes in front or behind the other is called an eclipsing binary. Question 44, the heliosphere is created by the sun's solar wind, and it's that big bubble of positive pressure that generally marks the edge of our solar system. By the way, while I'm at it, I had to double check. Actually, the heliosphere, I said that the heliosphere contains the Oort cloud, and I was wrong. I was wrong because I double checked. Actually, the Oort cloud is beyond the heliosphere. Pretty sure I got that right off the internet. So these were each 3 points apiece, and I tried to be consistent as I graded each of yours. Every once in a while, a student will come up to me after the test and say, well, I don't think you quite gave me the number of points I deserved here for this question. So feel free to try me if you think so. But question 45 was explain how the northern lights are related to space weather. And of course, space weather is the activity of our sun. And when we get those northern lights or the northern lights, what's happened is that the sun has sent charged particles that can't be accommodated by our Earth's magnetic field. And so Earth's magnetic field is what we say overloaded. So I was actually looking for something about the magnetic field and counted off at least one, I think, if you didn't mention the Earth's magnetic field. Question 46, I wanted you to both list and describe the layers of the sun's interior, not the atmosphere, the sun's interior. So we have the core where fusion is occurring, the radiative zone where the random walk occurs, the convective zone where I have, cells of rising warm and sinking cool material. Now, again, let me know if you have any questions, but if you simply just listed the layers of the sun, even the interior and the atmosphere, I did not give you full credit for that. Question 47, generally draw an HR diagram and label the axes and show the various groups. So not bad. So you can kind of see I was after along the x-axis. Of course, we have temperature from hot to cool, and that corresponds with the "Oh, be a fine guy, kiss me" stellar types. And then along the y-axis, we have luminosity, increasing luminosity as you go up. The main groups, of course, we have the main sequence here is kind of a diagonal from the upper left to the lower right. And then we have a group, kind of a cluster up here, giants, red giants, supergiants, and then a cluster down here, white dwarfs. That's kind of what I was after. Question 48, I wanted you to at least give me one difference between the two types of star clusters to get full credit for this. So we have our open clusters, which like the Pleiades are a beautiful open cluster. The ET cluster, some of us saw through a telescope, for example, open cluster. They're younger stars and they're kind of spread out. Globular clusters then are older stars, and they are more like a ball or a sphere of stars, and they are located in the halo region outside the plane of Milky Way galaxy, versus open clusters are more located in the disk of the galaxy. So for 49, is it likely that our sun could be involved in either a nova or a supernova type 1A event? And you had to remember that both nova and supernova type 1A events involve actually a white dwarf, which our sun is going to become, but getting dumped on by a companion star, which our sun does not have. So in order to get full credit, you know, and I actually think took off 2 points if you did not mention the idea that the sun needed a companion star. So that's what's the most important for that. So question 50 was to say, how can we use stellar parallax to actually calculate the distance to a nearby star? And I thought you guys had a lot of good answers in this one. And so I kind of drew the figure, and some of you guys did too, of if you have a nearby star, it will look like here, it looks in position P1 for here, okay? And as the Earth changes position around the sun, that nearby star will look here, P2, against the background stars. And some of you had some great kind of summaries of this phenomenon, because you said that the closer the nearby star, then actually the bigger change it will be against the background stars. And what's what we call, our scientists can use that this angle right here as a parallax angle to understand the distance to the star. So let me know if you have any questions.